Sometimes they refer to these ones as limitations of a primary surveillance radar. This can be either disadvantages, or we can also refer to them as limitations. One of the things that we said that actually is a disadvantage, which is coming out clearly here, is the presence of, you are not able to identify the aircraft positively. I cannot say that this is Muhammad. I cannot say this is Muhammad. And that one brings confusion, because if I exchange Muhammad with Adil, I will see the same person. Okay? So positive identification lacks. So we have got positive identification is lacking. The other thing that is lacking is the altitude. I don't know how high the aircraft is. I have to use radio to ask the aircraft the height at which they are flying. So I don't know the altitude. The other thing we have is high power consumption, because the signal has to go and come back. So we have got high power consumption. Number 4 is what we have discussed, the issue of noise. Very many things can reflect the signal, and when they reflect the signal, they come back and they come as noise. Now, depending on how big they are, some of them can completely cancel the effect of an aircraft in a place. So we have got this thing which refer to as clutter. The noise which comes in is called clutter. Okay. So these are the things which actually are being discussed in this area. The PSR system works well in low traffic areas. However, as the traffic increases in a given area, the PPI display becomes cluttered and specific targets may become difficult to distinguish from one another. Okay. Also, since the energy of a radiated RF signal is attenuated as the square of the distance travels, the resulting weaker returns are accompanied by noise, which tends to obscure the displayed target. So we have that one. We have got the effect of noise because of the distance which is traveled. Then targets may also be lost due to ground clutter from terrain and precipitation, unless a moving target indicator circuit is employed to detect and display only moving targets. Finally, the PSR has the distinct disadvantage. This is a very important disadvantage which normally comes in very clearly, in that the operator has no way of knowing the altitude of the aircraft unless the pilot reports it. Okay. Even the identity. So we must know. We must talk of the identity and the altitude. We don't know unless the pilot tells you whom they are and at what height are they moving. So, looking at this, there was a way of improving this situation such that some of this can be removed. And that is why researchers came up with an idea of having an air traffic control radio beacon system. So we have got air traffic control radio beacon system, which is ATC RBs, These are systems which then they were thinking that they could use them to mitigate against these problems. So, Bwana Mohammed, you can start with that. It is page 12, the last paragraph. The ATCBs, TCRBs.
The ATC CRBC is intercorroborating the use of secondary surveillance radar in conjunction with the airborne radio beacon transponder. The SSR was developed from the military identification frame or for IFF system, in which an airborne radio beacon transponder responds to ground radar integrations on one frequency by transmitting code reply on another frequency. The coded reply display as short lines on BBI allow the controller to identify the various target by having each one send back a different coded reply.
So here we are saying that, okay, we have got all these problems. Now the military people came up with a method which could be used after doing some research. They came up with a method which could be used to mitigate against some of these things. They asked themselves, supposing we have got a system which can send information directly to the aircraft, and then the aircraft responds. So we are going to send a message to the aircraft. We are going to ask the aircraft, who are you and how high are you? Then the aircraft is going to respond to us, telling us their identity and how high they are. Okay. So this is what they started with: identification, friend or foe. Yeah. Okay. You are sending a signal. You want to, because of identification, we have got I, F, F. I, this F, that F. Identification, a friend or a foe. Are you my friend or my enemy? You have entered my airspace. Okay. Now, for the military, that was very simple, because you are either a friend or an enemy. Their main object is not for safe passage from one unit to another, but their main object is for protection of the airspace. So here is a situation where they came up with this method, and using this method, they could send some things from the ground equipment. They could send some interrogation pulses, and then when they sent interrogation pulses, the system inside the aircraft was able to reply in a certain format, because aircrafts from a certain country will have the same format. If they are friend, they will reply with using certain codes. If they are enemies, definitely they are not going to reply. So if an aircraft enters your airspace and you ask them whether they are a friend or an enemy, and they are not responding, then they are automatically an enemy. Okay, because they cannot have the code of the friend. and that is why they cannot respond. Okay. Here is a situation where I'm asking Mohammed, are you Mohammed? Okay. But Mohammed, to respond to me, he must have a definite code. He must have that badge that says Mohammed. Okay. But Adil is the one who is in that area. If he takes out his code, it will read Adil. Okay. So the best thing he can do is to hide it. So either you respond, if you respond, you are a friend. If you don't respond, you are an enemy. So this was the essence of this. Now, so what are we saying? That on ground, we make interrogations. Ground equipment. And the ground equipment, they call it an interrogator. It is going to ask questions. Who are you? How high are you? In our situation. But with IFF, the only question which was there is, who are you? Yes. If you tell them whom you are, that's fine. Now, in the aircraft equipment, we have something we call a transponder. We have a transponder. What does the term transponder stand for? It means it's a transmitter, responder. Okay. It is a transmitter, responder. It's supposed, so from this, we now remove that, and we remove this, and we remain with the transponder. Okay, it is a transmitter responder. It's something that is responding to our interrogation, and it transmits the information to us. So what does it mean? The ground equipment is having an interrogator which has got both a transmitter and a receiver. The transmitter interrogates, and when the information comes, it's able to be processed by the receiver. In the aircraft, we have got a receiver also. The receiver is going to get information from the ground, is going to process it, and after that, is going to respond to our question. So this basically what we have. We have got ground and air. So let's continue it in a coded format. That is how the information goes into the air. But let us just continue. The information which comes from the area comes into a display, like what we were seeing yesterday. But then we have got a lot of traffic within the area. So we cannot have one controller manning the whole airspace. So we have to separate the areas where the controllers man. And that is why we have things like tower, we have things like approach, and we have things like area. But even in approach, like you people now are going to be working in the approach control, I need to have several displays, because I cannot have one person only doing the approach control. I need to have a number of you, such that I can even divide the area into segments, such that I can have one person checking one segment and another person checking another segment. Like in Jomo, we have got two segments. We have got the southern segment and the northern segment. So you'll have one controller checking the southern segment, another controller checking the northern segment. So this is basically what they are saying. The work which a controller does is a lot, and it requires a lot of concentration, because any slight mistake actually can be very harmful. Any slight mistake can cause an accident. So you want this person to concentrate and be able to ensure that actually the separation is maintained. So this is basically what they are trying to explain, that the information is displayed on the PPI, but this PPI information must be interpreted by the controller, because the controller is the one who is doing situational awareness and monitoring. Very, very important for that. So let us continue. The paint. Okay. Now, the replies that come from primary reader are referred to as skilled paint replies. The main reason is that based on the paint on the surface of the aircraft, we are able to get results. So that is why they nickname it skin paint, because it depends on the paint, on the reflection on the surface of the aircraft. There are certain materials. If you paint the aircraft with certain materials, then the aircraft will be invisible to electromagnetic radiation, and therefore you will not be able to see it. The military people have got some aircrafts which cannot be detected by radar, and it's because of the paint of the paint they have used to paint the skin. So this is what actually it means, the skin paint. Now, the other thing which we are talking about here is that we select codes. We have got our SSR, and when we have our SSR, we decide on the type of codes we want to receive. So it is not that any aircraft will detect any code which we send. There are some codes that will be neglected. So what does that mean? That the pilot can manually tune their transponder to the code they want processed. Okay, so they can manually tune the transponder to the code they want processed, especially in mode W. And mode W is the civil military mode, which we normally also refer to as mode 3A. When we went to the radar place the other was it yesterday? I showed you that we could tune that transmitter to 3A. You can also put it on 1 or 2, but our case was actually put it on 3A. And then we had a mode interlace where we were having 3A and then CC. What it meant is that when the interrogator is interrogating, it's going to send a signal on 3A and then send another signal on C, and it interlaces them. It keeps interchanging them. So what the transponder will get, the information the transponder will get, is the question, who are you and how high are you? Because mode C is asking the transponder, how high are you? Mode A is asking the transponder, who are you? So this is basically how the mode interlace takes place. Now, if the pilot has selected, let's say, mode W or mode 3A, and then the interrogator is interrogating in mode 2, okay, then the transponder will not respond to that, because the interrogation is not meant for it, so it will not respond. Okay. So this is basically how it works. Now, there is something else which we are talking about. We are talking about mode C. Mode C is asking about altitude, and actually the altitude is pressure altitude, which means that there is a set pressure which is going to be compared, a set pressure at sea level. So then the aircraft is going to compare the pressure which it has at the place where it is with the pressure at the sea level, and giving the difference should be able to calculate the height. So there is a lot of computerization. It's not really manual. They are now not using manual systems. The aircraft is using what we normally refer to as a flight management system, which is a computer to be able to get this information. So now, another thing which this explanation is actually assuming is that we have got this primary and secondary radar collocated, that they are together, and therefore they are synchronized, and the whatever in the information we are getting is coming up together at the same place. So if I'm seeing Muhammad, I'm seeing Muhammad as the dot from the primary radar, and I'm also seeing the information about Muhammad from the secondary radar. We have collocated. So now I'm having very clear information of who is in my airspace. Okay. Two systems. We have got a ground station and we have got an airborne equipment. So it's like we have got two systems. We have got a ground system, we have got an airborne system. Ground system is the interrogator, the airborne system is the transponder. We have said that the transponder stands for a transmitter, responder, and that's why we call it a transponder. Now, sometimes, because you will see different terminologies, but the most important thing is just to know that this is a responder. It is something which is responding to the information which you give it. Okay, let's continue then.